When you work with generative AI, the way you evaluate goodness of your models differ from traditional machine learning style of doing model evaluation. You can't use typical accuracy, recall, F1 score, etc. here. So what are the ways in which we evaluate our LLM outputs? We will try to understand in this video. Let's start without any delay. Let's try to understand what are the challenges with LLM evaluation first. Then we will see what are the intrinsic and extrinsic methods of doing evaluation of LLMs. So these are two different categories. We will see what is that. We will understand what are the various methods falling in these two categories. We will do a use case brainstorming. This is very important, guys, because the world of generative AI is very open-ended. Okay, so I can't tell you that what will work always. So we will take a use case and do a brainstorming to understand. This is very important part of this video. And then I will tell you way forward if you have to integrate evaluation in your pipeline, how you can do that. First of all, why is LLM evaluation challenging? There are very important, very critical few points that you need to understand. First of all, outputs of LLMs, right? Outputs are open-ended. So, for example, if I ask you, if I ask an LLM, what is the capital of France? So it can say that capital of France is Paris or Paris is the capital of France. Both the sentences are correct here. So outputs can be correct and it can be presented in a different way. Output can be wrong and it can be presented in a different way. So basically, outputs are open-ended. So you need to be careful on how you are evaluating your LLM. Second thing is semantic correctness. So uh, same thing can be said in two different ways and it can be true or other way around also. Same thing can be said in exactly same way and it may not have the same meaning. So for example, walking on the bank of river or bank as a financial institute. If you take these two examples, right? So the word bank is there, but semantic meaning changes. So semantic correctness is important. And one more thing in the same, fluency also matters. The reason being what you put after what is critical here. So this is another reason why when you evaluate, you can't just evaluate word to word. For example, in the example I gave you bank, right? You can't simply say if bank is there, then the response is correct. No. So semantic correctness and fluency is important. Another critical thing that you need to be mindful while generating your outputs, right? When you deploy production grade applications, right, then you need to be aware of these things. So hallucinations and toxicity, so you need to take care of these things. How you take care is tricky. Let's discuss on that. But you cannot have a AI app which does these two things are dangerous. And then whenever you want to do real evaluation, right, it may require a human judgment. So I will write here need of human judgment. So, for example, if I tell you this video, right, the video which you are watching now at Unfold Data Science, if I tell you take the all text of this video and create a summary out of it, and you give that summary to somebody who doesn't know anything about data science, AI, or machine learning, what will happen is that judgment will not be correct. So you need to have a proper judgment through a person who knows the subject. That is one way of doing it, or an LLM which can tell you that, okay, this is contextually correct, this is factually correct. So uh, basically, you can't have a one size fits all thing here. So these are some of the challenges that makes your evaluation of LLM difficult, right? LLM evaluation means we are talking about many kinds of apps here. We are talking about question answering apps. We are talking about chatbots. We are talking about some kind of summarization apps, machine translation app, and whatnot. So keeping all the apps in mind, these are some of the challenges you will face when you go to deploy a AI app or evaluate an AI app. Now, I told you that there are two different ways of evaluating your LLMs. So what are these two different ways? Let's try to understand intrinsic and extrinsic methods of evaluation. So your methods of evaluation methods of evaluation will fall in two categories mainly. One is called intrinsic. I will write I here. Another is called extrinsic. So what is the definition of intrinsic and extrinsic evaluation methods? So to keep it very simple, you will compare your output quality against a reference data. Okay. So in intrinsic, what you will do is you will take your output quality and you will compare against a reference data. Suppose you are fine tuning an LLM. You fine tune using two different ways. So both the outputs you will take and compare with a reference data. That is called an intrinsic way of evaluating your model. Or you can also evaluate in this category using linguistic criteria. So if I'm printing something in English, if I'm doing a machine translation, then how the sentence structure is coming, how the words are coming, how the grammar is coming. So all that category will come under intrinsic evaluation because you have a reference to evaluate against, direct reference, right? The other category of evaluation is known as extrinsic evaluation. What is the meaning of this? The meaning of this is I do not have a reference data. I do not have something to compare against, but I have some indirect way of seeing how my model is performing. For example, if I'm capturing a click-through rate, just an example I'm giving, suppose I generate a text from an LLM, fine-tuned LLM, and I ask users to click on some link. So is there an improvement in my click-through rate when I generate that text from model 1 versus model 2? That is one example, right? Suppose I write a blog using model 1 and model 2. So what is the average read duration of that blog based on model 1, model 2, etc. So basically what I'm saying here is you will evaluate your LLM by looking at result of your generation through some indirect ways, not a direct way of evaluation. So what will be different methods in this category, these categories basically? First method is very simple, that is called accuracy. I will show you all these one by one. Second method is called F1 score. And the way you compute F1 score is slightly different than traditional classification method. Third one is basically something known as BLEU score. Fourth one is something known as, we call it ROUGE. Okay. Fifth one is something known as perplexity. Perplexity. There is a company also with this name from Mr. Arvind Srinivasan. And BERT score is another method in this category. These are the methods that you will use most of the time when you are doing a comparison against a reference data or a linguistic kind of check. These are the methods you will use. When you talk of extrinsic methods, right? So if you want to compare, you don't have a reference data. So you want to see, uh, for example, factual correction. So suppose you ask to a model, what is the, who is the author of some book? And then you want to do the factual correction. So one example of this could be factual correction. Factual correction could be done using different tools, but I will write here factual correction. Okay. Another method in this category could be LLM as a judge. LLM as a judge. So what you are going to do is you are going to pass the outputs of two different models to the LLM, for example, ChatGPT, and ask ChatGPT to tell you which output looks good based on your criteria. Third category could be human judgment. Human judgment, and this is usable in highly sensitive domains. So I will give you some examples. Uh, let's say you are preparing a summary of some medical reports. So in these kind of sensitive domains, right, you must need a human judgment. We will talk about all these one by one. So first of all, I will start with a basic one. What I will do is I will tell you what it is, what it is, how it works in Python basically, how it works, and where to use. Where to use. Okay, I'll tell you about these. If you're liking the video so far, guys, don't forget to give me a like and a comment. Your likes and comments are the motivation for me, and I will keep creating these kind of content if you keep giving me likes and comments. Okay. So what it is, first of all, let's go to our first one. And first one is very simple one, accuracy. Accuracy can be used. So there will be a reference data, obviously, when we are talking of accuracy. So suppose you are building a sentiment classification problem and your reference data is something like 1001 for 4 sentences. Basically, I am saying positive, negative, negative, positive. This is your reference, let's say reference, and this is your prediction 1001. This is your prediction. So what you are going to say here? You are going to say my model is 100% correct, right? If you ask a LLM what is the capital of France, suppose your prediction says Paris and your reference says Paris. What you are going to do? You are going to say that my model is 100% correct. How to do that in Python? It's very simple, but let me explain you one more because these two are related. So another one is called F1 score that I told you. What F1 score will do is, from your understanding of machine learning, I know all of you are experts in machine learning. So F1 score is basically balance between precision and recall, right? Balance between precision and recall. Now you might be thinking, in the world of text generation or in the world of question and answering, right? How these things will come into picture. So precision simply tells you how much of, pay attention here guys, precision tells you how much of prediction is correct. How much of prediction is correct. Now the definition of correct here is as compared to the reference. And the recall tells you how much of reference is covered. How much of reference is covered. Let's take an example to understand this. If I say that my prediction is the capital is Paris. The capital is Paris. This is my prediction. And my reference or my ground truth is Paris is the capital. So here the prediction and reference, how much of prediction is correct. So it will see all the words shared tokens. So here it will see which are the shared tokens. So in this shared token, Paris is the shared token. Yes. So let me write here. Paris is the shared token. Yes. Is. Yes. The. Yes. Capital. Yes. All four are shared token, and all, total number of words in both is 4 only. So both these will be 1 in this case. How much of prediction is covered? So total prediction is covered. How much of reference is covered? Total reference is covered. Hence it will be nearly 1. Your F1 score in this case, nearly 1. Okay. So what I'm going to do now is, or 100% you can say, I'm going to go to Python and show you these two first, and then we will move to the next one. So these two are very simple to understand. We won't spend much time also. I'm pasting a code here. I'm importing evaluate numpy. 2 times I've imported. Let me delete this. And BERTScore I will use later, but I'm just importing it here. Okay. So prediction from model A is this. Prediction from model B is this. Ground truth means the actual reference data. I'm loading evaluate, and then if you take accuracy.compute, right, you are going to get prediction for both the models. As I told you, prediction is a simple thing to understand. Now let's try to do we can also do a prediction using manually like this. For example, why true is Paris, Tokyo, Madrid, and why pred is Paris, Tokyo, Barcelona. What we can do is we can simply compute a prediction like this. Okay, so comparing one by one. So when you will use accuracy, you will use accuracy when full match matters. And I will write here when full match matters and mostly for classification scenarios. There you will use accuracy. But in general, right, we don't, I mean, classification is just a small part of entire LLM AI app, right? So if partial correctness matters, for example, in question answering systems, imagine a question answering system where partial correctness matters. There we will use F1 score. See carefully what this F1 score does. I was giving you an example of capital is Paris and Paris is the capital. Prediction, you will take and split it lower. Truth, you will take and split it lower. Set and set means unique tokens. It will see the unique tokens. And now what it will do is it will see what is the length of unique tokens. So here length is 4 in our example. And here also length will be something. Let's say whatever we, Paris is the capital and capital is Paris. Same thing I'm passing here. So length of common token will be how much? 4. Length of predicted token 4. Length of truth token 4. So precision is also 1. Recall is also 1. So in this case, I think should be 1 or 100%. Right? So this is your F1 score. Little different from your traditional F1 score, but this is how it is. Right. What we are going to now, we are going to do a next one that is known as BLEU score. Let's try to understand what it does. So this is telling you basically how much is the overlap with reference. How much is overlap with a reference. Fine. So let's say prediction is France capital is Paris. France capital is Paris. And reference is what? Reference is the capital of France is Paris. The capital of France is Paris. So this is your, the first one is what your model is predicting. Second one is actual answer, right? What this is going to do is it is going to check 1 gram to 4 gram everything. So what I mean to say by 1 gram to 4 gram, somebody who is a seasoned data scientist should tell me in comment. Okay, I'm not going to explain you what is 1 gram to 4 gram. From 1 gram to 4 gram, it will match. Check 1 gram to 4 gram matches between prediction and reference, and then penalizes. It will penalize missing, missing, or reorder. So if something is missing, it will penalize. So actually what it is expecting this complete sentence. But here it is getting this sentence. So what it will do, it will compare prediction with reference and it will penalize you for missing or if you have reordered something. So let's see how BLEU score can be computed in Python first. And there is one more which is very similar to BLEU, and that is called ROUGE. So let me explain you that as well. ROUGE score. What this score does is how much of the reference is covered. So how much of reference is covered. What is the meaning of this? Meaning of this is if the prediction is the cat is on the mat. The cat is on the mat and reference is the cat sat on the mat. So you will see here when you do a ROG comparison, right, you will see ROG1 score is very high because it will have high recall. Recall means it is just trying how much of reference is covered. This is your reference, right? This is your reference. Out of this reference, how much of that you have covered basically. So that it checks in one way it is taking recall, and you will see that a high ROG score will come when you do this. Here what is checking, what is the difference between BLEU and ROG? It will check how much is covered, and it will check the basically how you are moving the sentence, so position of your words as well. So in one way you can say BLEU is more stricter. Now how to implement these two? I can simply go to Python and I can say you can evaluate, you can import, and I'm saying generated summary and reference summary. The cat is on the mat, the cat is on the mat, same thing I'm giving. And let's say cat sat on the mat. Okay, and if I'm taking first BLEU, then let's see what happens. So you see here the precision score is coming for the words, and there are different scores coming. So for example, length ratio is 1, because the number of characters here and number of characters, not characters, the tokens here are same, so length ratio is 1. Translation length and reference length both are 6, so length ratio is 1. Priority penalty is 1, and then this is precision, and these are basically uh, for important words it's giving you. So now what you can see is BLEU score is less here. Now let's make it for some time, let's make it same, and you will see that BLEU score is high. The reason is it is, as I told you, right, n gram, 1 gram, 2 gram, it will compare. Now if you remove something from the end, right, still some grams will be available, so it is going to give you some result. See here, okay, it is going to give you some result, and then what it is going to do, it is going to let you know how your different grams are covered in the sentence. And then row score is simply telling you uh, one kind of recall. So it will go to the reference and it will tell you that okay, everything is covered. So the cat is on the mat, the cat is on the mat covered. Now if I increase here, right, peacefully I will say, so now everything in the reference is not covered, so this score will come down. So as you can see, this is 92% now. So you can read about raw 2, raw L, raw some, there is small difference, don't worry about that. So 0.92 is the percentage. If you increase it peacefully and quietly, it will decrease further because you are not covering everything. Okay, so this is basically in one way reference. Two more scores I told you about. There is one more score you should know about, and that is known as perplexity. So what is perplexity basically? When you are generating a text, you means whenever I say you means your LLM. So if I say the capital of France is, then something will come here, right? So when you are about to fill this word, you means your LLM, then what is the confidence you are in this word? So suppose I say that I'm 90% confident that this word is going to be ABC. This is not a very good scenario. The reason being, there is a high chance of some hallucination here. So the good model will say that my confidence level is 60% on this word, just an example, high level, and my confidence level is, let's say, 30% on some other words, 10% on some other words, 5% on some other words, like that. So what perplexity tells you is, if the confidence is lower, if the confidence is lower, then it's a better model and it will have high perplexity. High perplexity. So I forgot to tell you about which which situations you will use BLEU and ROUGE kind of scenarios. So let me give you one example here. Then I will tell you about Perplexity. So BLEU scores you will normally use for machine translation. As I told you, this will check the sequence 1 gram, 2 gram, 3 gram, right? If everything is translated properly or not. ROUGE score you can use for text summarization. Why? Because we want to see if everything is covered or not covered. That's it. So one example use case for these two. And what we are going to do is we are going to run a simple perplexity example here and show you how you can compute the perplexity from a GPT kind of model. So this is a GPT kind of model. And here it is just trying to, basically it is trying to tell you here, if you see this, right? Perplexity is getting computed, that is 60%. So if this value is 90%, 100%, right? That kind of model we don't want normally. So this is perplexity that basically tells you language modeling, fluency, these kind of use cases. So I will write here so that perplexity is used in language modeling, fluency kind of tasks. And then one very interesting and my favorite I want to know about is called BERTScore. And at the moment you hear BERT, you must be aware that BERT is always checking semantic meaning, and that is pretty interesting for me. So all the while, whatever we are checking, right? We are checking if that word is present or not present, if the sequence is proper, not proper. Let's count how many words are captured. All these are doing that. But BERT is the first which will just give you contextual embedding internally. Basically, it will do contextual embedding and it will tell you how your prediction and reference are related or working together, or what is your score. So BERT will also give you a precision score, a recall score, and F1 score, but internally it will use your contextual embedding, which is powerful. So this is your BERT embedding, and in what scenarios you will use BERT embedding. So basically every time you need a semantic meaning. Whenever you need a semantic meaning, you will go for this, and most of the time you need semantic meaning. So BERT is one thing you normally have in your uh, evaluation pipeline. Now I want to, let's go back to our note here, and there is a homework for you here, and I will tell you one thing you have to do. For factual corrections, there are some packages available, right? So I want you to do some investigation on that. So if you have heard of something known as SERP AI, okay, go and do a investigation on this. SERP AI or SERP AI. Let's search once. SERP AI. Yeah. So you can use this and you can do the factual correction. So let me know in comment if you are able to do very simple code, 4 lines of code I could have shown you, but I wanted to give you I want you to do something in this. There is another called RAGAS. RAGAS. So let's search this once. RAGAS. That provides supercharged evaluation of large language models. I want you to do little experiment on this one. Okay. This is also helpful to give you a factual correction for your LLMs. So it will ask you to create API key, create it and build it. If you want a full demo, I can give it, but there is nothing much in this. See, get started, you do a pip install and you run some simple code. See here from singleton, BLEU score, and you can do other testing also, for example, factual correction, etc. Fine. So you can do this. And what I'm going to show is how you can use LLM as a judge, because that will need prompting. So what is LLM as a judge? I will use OpenAI's advanced model and I will tell to that this is my intention, this is what my results, and this is what my model. Now you tell me what is your thought. So I will ask to OpenAI, you tell me how you think this model is looking like. So here what I am doing LLM as a judge. See this here, guys. Import OS, so import OpenAI, import user data. I'm taking my OpenAI key. So I'm GPT judge, I'm defining, I'm giving question, response A, response B. Okay. And here basically I'm taking the responses and saying which response is more accurate, fluent, and helpful. reply only with A or B. And I can add many things here. You can add many things here, of course. Question is this: what are the key benefits of using renewable energy sources? Answer is this: renewable energy sources like solar and wind reduce carbon emission, provide sustainable power, and help it fight climate change. Answer B: using renewable energy is good. It's better than fossil fuels and it's the future. GPT judge question answer 1, answer 2, and GPT just says it will say which answer is better in terms of accuracy, fluency, and helpfulness. GPT-4 judge says A. So in this case, A. What I'm trying to tell you is this is a scalable way of evaluating your LLM model. If you have money. Now, if you don't want to spend money, obviously you can go for some free tools or free models. But advanced models like GPT-4 and all, right, very good at these things. And LLM as a judge is what you will see in many production grade AI applications, right? So that is LLM as a judge. Next one is human judgment. Human judgment is something I can't give a demo because of the name itself, right? So you take as I gave you the example, right? You take the text of this unfold data science video, you give it to someone, and they tell you that whether this is looking like good summary or not good summary um, based on the explanation. So that's human judgment. Now, most important part of this video, guys, what I'm going to do is I'm going to take a use case and I'm going to do a brainstorming on what we will use and why. All use cases are different from each other. So let's take a use case. What is my use case? So what is my use case? My use case is summarize scientific articles. So there are a lot of articles that you need to summarize for whom? For a researcher. So basically you are building LLM tool that will take scientific articles and summarize for a researchers. Now, if I have to tell you what are the requirements, what you will tell me? Requirements means what your LLM app must do. If I have to write few things here, I will say informative. Basically, your app should be informative. It should be concise, right? It should not like give lot of not information, lot of unusual things to read because researchers time is important. Then you cannot give anything that is incorrect. So factually correct, right? And what you need the fluency because you need good grammar, good sentence representation, right? And there could be more. There could be more. I'm just writing few things out of my mind here. So think about whenever you go on to build a production grade AI app, think about what are your requirements. I'm just trying to give you one example here, right? Now we know our requirements. What I'm going to do is I'm going to tell you how you can do a layer wise evaluation of your LLM. So I will call here layers. I will call here method and I will call here purpose. Obviously one approach is not sufficient. So I will go by layer wise approach. I will use different methods and I will tell you what is the purpose. So first of all, what I will do is I need to be semantically correct and the summary should be proper, right? So what I'm saying is the first level of check I will do is semantic meaning of my summary should be correct and the it should capture what is there in the sentence, right? So basically recall I'm trying to tell you, right? So suppose you have a reference summary and your LLM is generating one summary. So what I will want to do is I will want to see if the semantic meaning is correct and if the everything is covered, right? So this will be quantitative, which we can measure basically quantitative and this will be reference based because we have a reference. We have, as I told you, right? We have a, while training the model, we have a reference. Now you take a moment and tell me if I have to do a semantic match, which one I'll go for? Okay. If you have commented BERTScore, I'm happy. But for semantic, you will go for BERTScore. And for recall capturing, right? You will go for raw score. So see here, guys, we are not going for BLEU. Why? Because BLEU is basically machine translation kind of thing you can do with BLEU. Because we don't want to see if everything is in that order only, everything is covered one by one. No. What we want is this is the reference. What is the recall basically? So we are going for raw score here and BERT score. What is the purpose? Our purpose is here surface level meaning capture. Understand these concepts, guys, and semantic meaning captured. So these two things we took care. What is my next layer? My next layer could be again quantitative and reference based. Sorry, reference free this time. Okay, reference free. What I want to do here is, as I told you, I will also want my model to be fluent. So what I will use for this purpose is in my second layer, I can have perplexity. Perplexity. And what I'm going to check here, I'm going to check fluency of my sentences, my creation, whatever my model is doing. So from this, what all we have captured? We have captured fluency. We have captured in some way informative, and we have captured in some way if it is concise or not, some way, but not completely. So let's add some more layer. What we are going to do? We are going to put a qualitative layer now, qualitative and a scalable layer. Now, at the moment you hear qualitative and scalable, you can think of LLM as a judge. LLM as a judge. And what you can do here is you can check here coherency. Coherency. You can check here facts as well using LLM or other method also you can use, not a problem. And you can check here quality of your output. So quality of your output you can check and you can scale it very easily because it's basically calling LLM with your responses, right? And then one more category, what you can do is qualitative and expert. And here you will need a human reviewer, human review. And as I was telling you before as well, in case of high risk assessment or high risk generation or high risk any kind of tasks, let me write here high risk assessment only. You will put a human review so that you are more confident. If you see this now, you have covered factually correct also. You have covered all these and obviously you can have more and you can see which of these methods will serve your purpose and you can create a pipeline which will take care of all these one by one and give you a solid LLM evaluation pipeline. What is the meaning of putting pipeline? Nothing fancy. You just go and whatever is there in this Jupyter notebook, right? You will simply call that one after another, right? It's just about writing codes one after another. So this was about LLM evaluation, guys. Please, as I told you, if you give me likes and comments, I know I have to create this kind of content. And see you all in the next video, guys. Wherever you are, stay safe and take care.